In the final session of the measure phase, we're going to talk about process capability. In general, process capability is how does my process perform against customer requirements. We'll talk about the capability analysis, explain the concept of stability, which is a process's performance over time, talk about attribute and discrete capability, as well as different monitoring techniques. Process capability uses specification limits defined by the customer. There is an upper specification limit and a lower specification limit. We can measure a process using sigma levels. Sigma levels are the standard deviations in relation to the standard normal curve. How many standard deviations are there within our process? Sigma is a universal measure of process performance. We can do that with variable data or attribute data. We can do it with several different types of metrics. And the sigma is that one universal aspect of things. So, process capability is defined in two ways. CP is the first measurement of process capability. What it measures is, am I able to do it? We take the upper specification limit minus the lower specification limit and divide that by 6 standard deviations, or 6S. What that means is voice of the customer over voice of the process. It is total tolerance over total spread. It says, can the process meet the customer requirements? You can see in the chart here the different values that correspond with a good CP value versus a bad CP value. The higher the CP value, the better the process is in relation to the customer requirements. CPK is the second measurement of process capability. CPK uses the mean in the formula, sample mean being X bar, and which is a measurement of central tendency. So as CP measures, am I able to do it? CPK measures, am I actually doing it? It takes the location of the process into account as well as spread. With CPK, we have to calculate the CP upper and the CP lower separately in order to find out which one is the smaller value. You can also see on the table there the different values for good and bad CPK values. Some rules associated with process capability. See if I'll point out rule number 2. CPK will always be less than or equal to CP. If CPK equals CP, we know that the process is perfectly centered. I mentioned sigma levels earlier, so how do sigma levels correspond with CPK values? Well, sigma level uses the specification limits from the customer and ties the center of the data using the mean, or X bar, and then divides it by the spread, which is standard deviation. You can see an example here. Long-term process capability uses indices referred to as PP and PPK. They are calculated the same way as CP and CPK. They just use long-term standard deviation versus short-term standard deviation. You can see here a comparison between CP and CPK against PP and PPK. Again, CP and CPK are short-term process capability. PP and PPK are long-term process capability.